Good day, my name is Zanele Makanya, student number 15102947. The title of my project is Smart Room Temperature and Lighting Control. In this project, I designed and stimulated a microcontroller-based system that automatically monitor room temperature using an LM35 sensors and matches the ambient light using an LDR sensor. According to this reading, the system intelligently controls a fan and LED lamp while continuously displaying the temperature, light level, and the system status on a 16 times 2 LED screen.
This system is useful in real-life applications such as smart homes, office, or classroom, where automatic control helps save energy and keep the environment comfortable. By automating temperature and lighting, we reduce manual effects and improve efficiency. The system works as follows. The LM35 sensors measures temperature. The LDR sensors measures light intensity. This signal goes through the ADC0804 and the 74HC4051 multiplexer. The 8051 multicontroller leads the digital value and makes decisions. The LED display temperature level, the LED display temperature, light level, and mode. If the temperature is above 30, the fan turns on. If the room is dark, the LED light turns on. A push button allows switching between automatic mode and manual mode. My process design. I use the 8085C1 microcontroller as the brain of the system. The LM the LM35 temperature sensor is connected to the multiplexer ACD to convert the alarm value. The LDR is connected to light. The ADC 0804 converts along a signal to digital microcontroller. The 74HC4051 multiplexer allows us to switch between the LMR35 and the LDR. The LCD, the 16:2 LCD displays temperature, light level, and mode status. The fan is represented by a DC motor, and is driven by a resistor. A push button, the LED lamp is connected through a resistor. A push button switches between automated and manual mode. Now I will demonstrate the system in automatic mode. This is how I make my profile, transferring the coding. This is my coding. 80, yes, press OK, OK, yes. Then I press target. This is C5. So I'm just gonna say Makanya. Okay, say paste. Then I select the is an output to transfer everything. Okay. This is my coding now. As you can see, it's 0 errors, 0 warning. So now I'm transferring it to my set. Yeah, this is the main. I take it as the main. Okay. Press yes, and then go to that. Say okay for this to work. Then I press play for it to transmit. Okay. So now, as you can see, my LCD is reading, so which is the coding is correct. So my circuit will now start working, and my LRD, whenever I turn it on, yeah. Okay. LM35 lower than 25, the fan will turn off. Fan will turn off. Sorry, the fan will turn off. Okay. Yes, whenever, okay, when I increase the temperature to 30 degrees, the fan start moving. So I increase the temperature to AIU. My LRD is high bright, LED off. As you can see, yes. I turn it, okay, increase it again. The fan turns on. So my LRD is on. My LED is on. So my LR. So when my LED is off, my LED turns brighter. And then when I switch it off, the LED turns off. When I switch it on, yes, the fan is turned off. When I switch it on, everything turns on. The LED turns on and the fan turns on. When I turn off, everything turns off. Between my LED and my fan. This system works correctly. The sensor responds correctly. The fan and the LED react in real time. The LCD display information clearly. The mode switch work perfectly. One challenge I faced was controlling two analog sensors with one AC, but I solved it by using a 74HC405 multiplexer. I also had to carefully adjust the transistor circuit to make sure the LED was not, the LED was not always on.
In conclusion, I successfully designed and stimulated a smart room temperature and lighting control using the AT51 multi-controller. I have learned how to interface sensors use an ADC and a multiplexer. Write embedded C code and control outputs based on a condition. In future, this system could be improved with wireless monitoring smartphone controlling real hardware complementation. Thank you for watching.